All right, so on this one we are going to graph an absolute value function, g of x equals the absolute value of x minus 3. From our chart over here on horizontal shifts, we can see that when it's a minus, it's going to go to the right. And notice that we had parentheses. When we have the absolute value bars, it's going to do the same transformation, okay, the same shift. So this is our common graph, and I'm just going to go ahead and show those that way. We're taking the absolute value of each of the x coordinates, and that gives us the y. Now we're going to graph this with the dotted graph. You could put more points on here if that's helpful to you. And so we've got our dotted graph on here, and then that is our common or parent graph. Now from here we have to decide, okay, I just told you that we're going to shift to the right because it's a minus 3, which makes that 3 a positive originally. And so we're shifting right 3. All right. So on the graph, all we have to do is count that, right? This transformation is just one way, and it's going to the right. So 1, 2, 3 for each point. 1, 2, 3. 1, 2, 3. And then this is where we will have a line drawn for one side of our, that line's looking kind of ugly. Let's see. I'm trying to turn this in a way that will make it easier for me. And then on this one, oops, I kind of missed there. And we have that nice V, and that's it, right? I guess I made one side a little bit longer than the other one, but that's really okay. It's normal. All right, next. Okay, so on this one we're going to do a reflection, because notice it says a negative x squared, and so that means we're reflecting about the x-axis. So our original graph, which is going to be the f of x graph, right? The function f of x equals x squared. So we are going to use negative 1, 0, and 1. And then when we square each one, we get 1, 0, 1. Now this is our dotted one because this is the one that helps us with the reflection, right? That's the transformation for this one. Okay, so let me do the dotted. Try to get that curve in there. Okay, so a reflection simply means that we are going to mirror this graph across the x-axis. And that's simply, right, we're going to have a vertex here. This point goes the same distance across the x-axis, and so does the other one. And so it becomes a reflection of the original graph. So what happens are my y's become negatives, right? At negative 1, I'm at negative 1. And at positive 1, I'm at negative 1. And then we simply draw our upside down parabola. And so we had a reflection for this one, right? So reflection across the x-axis, just if I folded it on the x-axis, these two should line up because it's like a mirror image. Okay, this is also a reflection. And we're going to actually use the common reflection, the common graph with a reflection. For this one, it just makes it easier. excuse me, you always want to do the reflecting part first and then the counting. So if we reflect, let me make this pink, f of x equals the square root of x, right? This is the reflection of that. And then it makes it easier for us with the g of x function because it reflects and it's going to shift. So it shifts. Oh, I keep getting back and forth with my colors here. Shifts left 3. Remember, we think kind of opposite of the sign that's inside this square root, and that's how we figure this out. Okay, so the points that I pick are 0, 1, 4, and 9 because it's still a square root function. Now, originally these would be positive, but we're going to go with the reflection, so that's what we're finding. Obviously, 0 is not negative. The absolute value of 1 is 1, and we make it a negative 1. The absolute value. The square root of 1 is 1, sorry. So is the absolute value, actually. The square root of 4 is 2, and we're going to make that one a negative 2. And then the square root of 9 is 3, and it's at negative 3. Now, by reflecting it with our parent graph, that just is going to make the rest of it easier because otherwise you're trying to reflect and count. And so this is my recommendation, is to go take your parent graph, your common graph, reflect it, and then use that to get the graph that you're supposed to be graphing for that problem. Okay, so let's graph these. We have 0, 0. At 1, we are at negative 1. At 4, we are at negative 2. And at 9, we're at negative 1, 2, 3. Okay. And so we're going to use our dotted, dashed way of making this graph. And now we can go to the next one. Okay, so we've already reflected, right? It's a reflection. We did that. And now we just shift left 3. Okay, so when we do the shifting, we're going to shift 1, 2, 3 from each point. 1, 2, 3. 1, 2, 3. And the last one, 1, 2, 3. It's weird here because we kind of almost run over the other graph. Something you might think about is, oh, we shifted over to negative 3. But notice if I put negative 3 in for x, I get 0. And so it's okay to use a negative 3 in this case because we have a positive 3 that we're adding. Okay, so we just draw our square root function. I'm having problems here. All right, so and there we go. A little bit of a squiggly line there, but we can pretend like it's smoother than that anyway. Okay, here's our next one. Okay, so this one is also one of those, okay, we shift around and we do different things. And notice I didn't say compare this to whatever. I'm going to let you come up with that. And most likely on a test I would do that too. Oh, and on this we also are finding domain and range. So let's not forget this part. Okay, so when we look at this one, we are going to compare it to, we'll just call this f of x equals a negative absolute value of x. Remember the common graph is the absolute value of x. We're going to go ahead and do that reflection like I explained on the previous question. So when we substitute negative 1, 0, and 1, right, the absolute value of negative 1 is 1, but then it's a negative because there's a negative on the outside. 0 is always just 0. It's not negative or positive. And then the negative or the opposite of the absolute value would be a negative 1 here. Okay, so that is our basic common graph. So -1, -1, and 1, -1. And then we'll talk about the shifting. What's going to happen to this other graph? Okay. So when we look at the h function, right, h of x equals negative absolute value of x plus 1 plus 1, we have more shifting going on here. So we've already reflected, right, there's a reflection, so it reflects, and then it shifts a couple of ways, right? It shifts left 1, right? So we have a shift to the left and up 1. So it gets a little trickier, but since we reflected it first, that helps. And now we're going to shift left 1, up 1. So for each point, left 1, up 1, left 1, up 1, and this one's left 1, up 1. And then we simply draw our upside down V, right? Notice we overlap on this one on the other graph, and that's perfectly fine. I didn't draw that side very long just to kind of show. Let me just make this one shorter to kind of match that one. And that's all you need, right? You have it with the shifting, the reflecting, and all of that. Okay, so I don't think I can, I've got 3 more examples. I'm going to go ahead and stop this video and then finish up on one more video.